Hello friends, imagine for a moment that you are floating alone in the vast silence of space, looking out into the endless ocean of stars, galaxies, and mysteries that surround our tiny blue planet. Just when we think we know our universe, something happens that makes us realize how little we truly understand. Recently, NASA has gifted us one of these humbling reminders through the eyes of one of humanity's greatest inventions. The James Webb Space Telescope. These are not just photographs. They are keys to our past, our present, and maybe even our future among the stars. When I first saw these images, I was struck speechless, and I promise by the end of this video, you will feel the same wonder that has captivated scientists and dreamers alike. So buckle up and allow yourself a few minutes to journey across time and space. Let's start with the telescope itself. The James Webb Space Telescope, lovingly called JATE, is the largest and most powerful space science telescope ever built by humankind. It's a symbol of our unending curiosity and a testament to what teamwork, patience, and sheer human brilliance can achieve. Think about this, it took over 25 years of design and testing, involved thousands of engineers and scientists, and cost nearly $10 billion to create this cosmic eye. That's a heavy price tag, but once you see what it can do, you might agree that it's worth every single penny. Unlike its older sibling, the Hubble Space Telescope, which orbits close to Earth, the James Webb sits at a special place called the L to Lagrange point. This is a spot about 1.5 million kilometers away from our planet, roughly 4 times the distance from the Earth to the Moon. The Sun and Earth's gravitational forces are perfectly balanced, letting the telescope stay stable and focus on the faint whispers of ancient light from the universe's most hidden corners. And it's cold out there, really cold. To detect the faintest heat signals in the universe, the telescope must itself be colder than space. It operates at around minus 266.75 degrees Celsius, just a few degrees above absolute zero, the point where all atomic motion practically stops. To help it survive, engineers built a massive sun, about the size of a tennis court, that blocks heat from the sun, and even the moon. If you're into photography, prepare to have your mind blown. The telescope's focal length is a mind-bending 131.4 meters. To put that in perspective, your average DSLR camera lens has a focal length of 50 millimeters. Webb's is over 2,500 times longer. Its main mirror is a masterpiece too, a giant honeycomb of 18 gold-coated hexagonal segments, altogether weighing about 705 kg. This mirror collects light that's traveled billions of years just to reach us. Imagine that. Light that left its home before the Earth even existed, now being captured by a telescope floating far beyond the reach of our atmosphere. But enough about the hardware, let's talk about what this golden eye in the sky is actually seeing. To appreciate these images, you first need to know a bit about light. The visible light our eyes can see is just a tiny slice of the electromagnetic spectrum. Beyond red light lies infrared light, which has longer wavelengths and can slip through cosmic dust and gas that block visible light. That's Webb's specialty. While Hubble mainly captured the universe in visible and ultraviolet light, Webb looks deeper in the infrared spectrum from about 0.6 to 28 micrometers. Why does this matter? Because when you look at a cloudy night sky, your eyes see darkness, but switch to infrared, and suddenly you can peek through those clouds and watch stars being born, planets swirling around their suns, and galaxies forming. This superpower comes from 2 main cameras, the near-infrared camera, or NIRCam, and the mid-infrared instrument, or MIRI. Each sees different parts of the infrared spectrum. Sometimes, the same object looks completely different through each eye. In one jaw-dropping image, we see a dying star surrounded by gas and dust. With NIRCam, you see a bright star wrapped in delicate layers of gas, almost like the petals of a cosmic flower. Switch to MIRI, and you can see 2 stars orbiting each other, while the gas becomes nearly transparent, revealing secrets hidden for centuries. That dying star is part of a phenomenon called a planetary nebula. It's a bit misleading. Planetary nebulae have nothing to do with planets. It is just a term astronomers use to describe the shells of gas that old stars shed as they run out of fuel and collapse inward. In our own far-off future, about 5 billion years from now, our sun will swell into a red giant, swallow Mercury, Venus, and maybe Earth itself, before puffing off its outer layers in a dramatic final act. One day, alien astronomers may see our sun's death, just like we see these faraway dying stars today. But don't panic, we've got billions of years to figure out how to avoid becoming stardust. Now, let us talk about the showstopper. The very first full-color image NASA released from the James Webb Space Telescope. It made headlines around the world because it has the deepest and sharpest infrared image of the distant universe ever taken by humankind. What you're really looking at is light that has traveled more than 13 billion years to reach us. The image shows a cluster of galaxies called SMACS 723. The galaxies in the foreground act like cosmic magnifying glasses through a phenomenon known as gravitational lens. Their immense gravity bends light from galaxies behind them, magnifying and distorting them in the process. This allows Webb to peek even deeper into the universe's past. Think about it. Every speck of light in that image is an entire galaxy, each with billions of stars, each star likely having planets orbiting it. Somewhere out there, maybe another intelligent civilization is pointing its own telescope at us, wondering if they're alone. Another spectacular image from Webb features Stephan's Quintet, a group of 5 galaxies caught in an intricate dance. Although they appear close together, one of these galaxies is much closer to us, just 40 million light-years away, while the others are about 290 million light-years distant. You can tell by the detail. The closer galaxy looks sharper, almost like looking through clear glass, while the distant ones appear slightly fuzzier. These galaxies are pulling and tugging at each other with their immense gravitational forces, stripping gas and stars and triggering bursts of new star formation. It's cosmic chaos on an epic scale. Then, there's what I consider the most breathtaking image, the cosmic cliffs. At first glance, it looks like a glowing, misty mountain range on an alien world, but it's actually the edge of a giant gas cavity inside the Carina Nebula nursery where stars are born. Those towering peaks are columns of hot, ionized gas and dust sculpted by radiation and stellar winds from newborn stars. Hidden in these clouds are infant stars, some just a few thousand years old, a blink in cosmic time. Think about it, we are literally seeing baby stars being born. Some of them might grow up to have planets, and who knows, maybe life someday. And yet, for all the stunning visuals, maybe the most groundbreaking discovery so far isn't even a photograph. It's data fingerprint of light collected from a faraway planet's atmosphere. Let me explain. About 1,150 light-years away from Earth lies a gas giant exoplanet called WASP-96b. It orbits its star so closely that it completes a full orbit every 3.5 days. The James Webb telescope watched this planet pass in front of its star and collected its starlight. Using an instrument called a spectrograph, scientists split this light into a spectrum, like a rainbow, and looked for dips at specific wavelengths, clues about what the light passed through on its way to us. And there it was. The unmistakable signature of water vapor, H2O. Not oceans, not rivers, but water molecules floating in the planet's hot, hazy atmosphere. Scientists even detected clouds and haze swirling around this scorching world, which has an estimated temperature of over 530 degrees Celsius. So, no, you wouldn't want to vacation there, but finding water this way is proof that the telescope works exactly as hoped. It's a game changer. This is just the beginning. Our galaxy, the Milky Way, may contain up to 300 million potentially habitable planets. So far, we've catalogued about 5,000 exoplanets, but we've barely scratched the surface. For the first time in history, we have a tool powerful enough to scan distant worlds for signs of life. Imagine what's next. Planets with atmospheres like Earth's, planets with balanced levels of carbon dioxide and methane, maybe even planets with biosignatures that hint at someone alive out there. One of the most exciting targets is TRAPPIST, a rocky exoplanet about 40 light-years away, practically next door in cosmic terms. It is similar in size and mass to Earth and orbits in its star's habitable zone, where temperatures could allow liquid water. In the coming months and years, Webb will focus its instruments on this world, analyzing its atmosphere for gases that life as we know it would produce. Imagine the headlines the day we detect something unmistakably biological on another planet. That day might be closer than we think, and beyond planets, Webb will rewrite what we know about black holes, dark matter, the birth and death of stars, and even the expansion of the universe itself. It is like humanity has gained a time machine, one that looks back billions of years to help us understand how everything came to be. Every time you look at the night sky now, remember, you're seeing only a fraction of what's really there. Behind that darkness hides a rich, vibrant, constantly changing universe full of wonders waiting to be discovered. The James Webb Space Telescope is our passport to this hidden universe, and we're just getting started. So, my friends, if you ever feel small, just remember, you are made of the same elements as the stars. You're part of this vast cosmic story, one that Webb is helping us read page by page, light year by light year. Thank you so much for watching this video and taking this short trip across time and space with me. If you enjoyed it, don't forget to like, share, and subscribe so we can keep exploring the universe together. Until next time, keep looking up and keep wondering, because the universe always has something amazing to show us.